Good morning. So today's class, we will finish this class and the structure. We will not cover the string and the strings. And the midterm only covers everything before this class. So it will cover something like types, arrays, vectors, recursions, classes, structures, and so on. All right, that's everything that will be covered. And yeah, so before doing that, I would still spend some time on this discussion problems. So can anyone tell me what's the problem of this code? If you guys have already checked this discussion part. So the idea is quite clear, right? If it's O and not the start position, a global flag may be assigned to true means we can visit the target. And that's the only place is PD is changed, right? And if it's not our destination, then what we can do is we can check if the next position is X. No, right? Yes, next position is X or O. It means we can visit the next position, which is X plus 1, which is going down, right? Going down. If we can go down, we can try down. If we can go right, we can try right. Right? Actually, it's quite clear from the ideas. There should be no problems if we don't think about the time limit, right? It actually the time limit exceeds. So it means whenever you have already tried and find one possible solutions, you will try another one. It may seems okay, right? If the total number of trials are limited, but if you think each time you are doubling the trials, if every time the first try succeed, right, you are doubling your number of recursions. So, and whenever the size becomes larger and larger, you are doubling the effort you are doing. So the question is asking whether you should put map xy equals w. You don't need to do that. It's unnecessary, but the question is you are doing too much work when you are doing recursions. So I just write another version. Yeah, I hope you guys can see it. I'll put it here. Yeah, don't need this large. It's a very short version, right? Again, reading the maze, right? And one trick I do is I would initialize the starting position to be X, so that in my code, in my recursion code, I don't need to check X anymore. I don't need to check O anymore, right? Whenever it's O, it means I have already visited the destination. So that's the first line, right? If we already visit this destination, we are done. We can return true. And whenever we hit a wall, it means we are going to the dead end, right? We cannot proceed. So we just return false. Otherwise, if we are in the position of X, right? If we are in the position of X, we can try down row plus 1, or try going right, going to the right side. And one thing I don't know if you guys can still remember, this OR operation is lazy evaluation. Right? What does it mean by lazy evaluation? If the left-hand side is true, it will not call the right-hand side functions. Right? This is called a lazy evaluation. If the left-hand side is true or anything is true. So it already knows the solutions. So what they can do is you can put in here, so the right-hand side will not visit. So yeah, basically this is something that the ideas, right? So what if you want to put some comments, right? How can you explain what does this one do? You can say, okay, it returns true if there exists a path from row column to destination, right? Destination, yeah. So as you can see, this traverse from row and column means it returns true when there exists a path from your current position to the end, right? So in this recursive call, it means, okay, if you cannot visit your destination, no, it means if you can visit from the position below you, or you can start from the position to your right, and any of them can visit to the destination, it means you can visit the destination, right? This is your recursive thinking. All right. Any questions on that? Because you guys have already done some work on it, so maybe understanding this one would be much easier, right? All right. Maybe we can try to run it. Here for the maze. -O maze. Wait, okay. I forgot to put a parenthesis here. We can group it into one. I read it in this style just to save some lines, right? Still remember this question mark? It's ternary operation. If it can traverse, return true, otherwise return false, right? And we put this one into our cout. So either cout true or cout false, right? Just in one line. Let's see any more. No. Run it. Let me see, where is there? OJ, yeah, here. Yeah, right? Here. If I put into the first sample input, it returns true. And if I put into the second one, right, it returns false, right? Right, very simple. Let's make it more complex. Okay, so how can we count? How many times each traverse are called? How can we count? What are the keywords to count how many times traverse are called? Static, right? We can use a static. Good. Let's use some simple examples to check how many times this one is called. All right, let's say 6 and 8. What is the input? Okay, like this. Put it in the middle. And the W, O. Let's assume everyone else are X. I can copy it for 3 times. Five. Oh. So 5, I can put something like this. And in 6, I still using walls to group them, right? As you can see, this recursive function are called 14 times, right? How about we change it a little bit so that each time when there's a solution, we still traverse to the other side. Right, so what do we change? We change it to if traverse to from the position, just be the second row, right? Be the next row, and if it returns true, means we can visit the next one, right? So that we can put a success to our current position to be success. And at the same, if we start from the position just right, and they can success, we can success. So basically, the functions are exactly the same. So let's see what's the difference. How many times this one are called? Wait, still this amount? Oh, I didn't compare it. Okay. Yeah, 300 times, right? Even though you find a path that will be successful, right? If you move one position down and it can success, you will still try the positions to your right, right? You will still try the positions to your right. So almost the number of function calls will grow exponentially. So that's also the problem in here, right? You will try to the right, you will try to the down, and when you try both, and you can see this one. Wait, there's another one, right? Our input is a very small one. You will call hundreds of times, and when this size grows larger and larger, it will become a more complex problem. Okay, so I believe you guys get this question. All right, let's make it even harder. How can we print the path? How can we print the instructions? Like the Hanoi Tower, right? We said move from 1 to 3, move from 2 to 3. How can we print the path? Print out right or down. How can we do that? How can we print? Move to the right or move down? And maybe our job would be easier if we could print just one solution. One solution would be fine. How can we do that? The idea would be simple, right? If I try this could work, what should I print? Let's make it a just a character. Row plus one means going down, right? And do something like this. What if this one can work? It means we can move right, right? We could let me erase it. I should modify it to be right. Going to right. Right. If I I try going down and it has success, I would see out, okay, go down. If I try going right, it has success, I print out going right. What's the problem of this? What's the problem? It will print out just some. Let me first erase these ones. They are not needed. They will output a lot of things, and they cannot see. Wow. Right, down, right. It's not possible, right? Yeah. You should a limited amount of times it will work. Okay, what's the problem? Yeah, you're showing all the tracks. So what we can do is, all right, we don't need this success, right? We can simply return true. So whenever it finds a solution, it's done. And I don't need this symbol anymore. Similarly, I can use this. And in here, maybe I can return false. All right. What's the problem of this? Anyone see it? There's still one tiny problem in here. The problem is it's printed in reverse order. Right, let's try it. Maybe this example is not clear because we can go to both directions. Would be fine. Let me see. It says goes to right, down. It seems workable, but let's try another one. It's actually printed in the reverse order. Yeah. From this old position, right? Wait. Yeah, it has goes down, goes right, hit a wall. It's actually printed in the reverse order. If we go down, right, down, right, down, right? This will be the correct solution. So what's the problem of here? Yeah, recursive call, right? Whenever it comes here, you will call this one function first. Then you print a D, right? It's similar to you forget about what they will print. When they are done, you will print your D, right? Similarly, when you are in the second level of this recursive call, you will do the third level of recursive call first, then print out the path, right? You are doing it in reverse order. But if you don't mind, it's fine, right? Otherwise, you can keep it in some arrays, in some path, so that you can print out these directions. All right, any questions on it? I can assure you, recursion will be there in our midterm. All right. Okay, let's make it even more complex. How can we change it to iterative style instead of recursive? Can we use a bunch of for loops to do the work instead of function calls? Think for a while. Any idea how to make it using for loops to do the work instead of recursions? there would be, let me do it. So we can create another version, right? Let's call it traverse 2. So what's our thinking process? Our thinking process is like this. Assuming we start with O, right? Let me use terminal. Assuming we start with O, it means this position we can visit, right? We can visit this one element by element. Whenever we see an element like this one, like this X, and highlight this one, and whenever we see an X, we can check if there exists a path from above or from your left, right? If anyone can be visited from the starting point, we can visit this one. If both of your, like this X, right? If both of your left side or upper side, you can never visit them, it means you cannot visit your current one. Right? This is the idea of changing to a for loop. So typically how we do it, we would create another, for example, Boolean function called reachable. It's not a one factor. One. Let me see. I can initialize a two-dimensional array of the reachable, the same size as maze, and initialize all of them to be false. And then what I can do is, I can set reachable of our current row and column to be true, right? These are something we can do. Because we are in our current position, we assign it to be true. Remember, it's not a recursive call, so don't worry about, okay, next time this one will be assigned to true. Don't worry about that. It's just one iterative function cost. So let's continue. What we will do is we will visit them one by one, right? And yeah, there will be some tricky things here, but I will skip that here. And what we will do is, okay, the reachable of the current position, it's equals to either your upper position is reachable or your left position is reachable, right? You could say something like the reachable of I minus 1 j, or is it or? Yes, or reachable of I j minus 1, right? You can do something like this. You will start from any position, right? If your left position is reachable or upper position is reachable, you are reachable. but there will be some cases. We only check for when the position is X, right? And for W, we don't need because initial value is false. So we only check for when the position is X. And what else? Yeah, we can. What else we can do? Let me see. Yeah, I think we are basically done, right? And only when we can check for the final position is that true or false, then we are done. Yeah, this code isn't finished. You can keep on working on it and finish this iterative operations, right? These are the basic ideas. When this position is this, you can do this. And the only thing you can check is the reachable of the this position, right? If this position is reachable, then you are done. So these are the iterative version. It's not complete. When you run it, it will fail, right? And you are responsible to finish it. Because I have to finish the classes and the structures, but I will talk about it here. Any question on it? This is the iterative version. As you can see, the thinking process of recursive and iterative are the reverse side, right? When you are thinking, you need to think about the recursive version, you would always assume, okay, the function already finished everything if I choose one position, right? Especially the position to my right and the position below me, right? I would assume the function's already done everything for me. But in iterative, it's different. You need to think from the beginning to the end, step by step, right? It's the opposite side. All right. Let me close it. Jump back to our classes. This one, so yeah, before that, I would still emphasize on why do we need to learn classes, right? So for instance, if we have a, let me create another CPP file. Right. I forget about the include something. So assuming we are trying to implement a system that maintains the whole universities, like how many students, how many teachers, how many classes, right? What you can do is, okay, I can define some classes, right? One class is called student, right? And what are the typical properties of student? Let me make them private, such as the you can have an integer, which is your ID, and you can have a string, which is your name, right? And you can have a bunch of vector of, for instance, just strings. Let me make it easy. Courses you have listed, right? Here are something you can do. And of course, we can have, let me simplify that to be just two classes. One is the student, another one is the course. Right, we can have, oh, I've got a semicolon. We can have a course. Right, inside a course, we can have some right, we can do something simple, such as just put some IDs here to represent the students, or we can call it student IDs. Student IDs, right? So we can also define some public method, such as, how about a student trying to register a course? Void register a course. Let the course be some strings, just as course names, right? Here is the typical way you put a in here, right? The student could register for some classes. Let me finish that. So in the course, we can also call something like the function such as the same name, right? Register a student's integer ID. Right. These are something we can do. We can define the same name, what is register keyword. Register. Just call it reg. Right. We can have the same name for functions, right? But the question is, this function and this function are different. And one more thing is, we have already learned something about the overload, right? When the function names are the same. But remember, these two functions are not overloading. They are different functions. These two are different functions. And what we can do is, okay, how about we put some of the implementations here. It's still valid, right? We can say, how can we register a course? We can do course dot push back the name. And in your register, we can do is, if we want to register a student, right? What we can do is this student IDs. Oh, the name is so long. IDs dot push back this ID, right? This is the way. And what's the beauty of it is that if you don't have a class, right? If you don't have a class, what you can do? Compared to with a class. So with a class in our main function, for example, we can create a student. Right? The student, for example, give the name Joe, right? We can give a course name, a course, let it be UFUG 601, right? What we can do is, okay, Joe dot, I want to register for the course. The name doesn't matter actually, right? You can use different names. And what else? The UFUG 2601 dot reg. Right, we don't know the name of the student yet, but let's assume their IDs are, for example, 1000, right? Oh, it's not type string. The type is integer.
For the register of students, the constant string add.
Yes, it should be a constant string. All right. 5. All right. Here are something we can do, right? So what's the job of a constructor? So the constructor is when you declare a student, right? You don't know their IDs, you don't know their names, you don't know their courses. So you have done nothing to their initial values for this row, right? I put 1,000 here, I just assume their IDs are 1,000. How about whenever we create a new student, we want to initialize their IDs to be 1,000, their name, and their courses to be initialized, right? So that's something we have learned when we talk about the constructors. So what we can do in here is we can create a student, right? Remember, there will be no return type, right? It will return the same object. Okay, don't forget about it. There will be no return type. And in here, what you can do is we said the best way to initialize its members are, what we can do is we can put IDs to some initial values, right? Assuming we want a default one. If we want a default one, we can put some IDs here, right? If the again, just to give a 0 here, and the name to be a test student, right? This is something we can do. We have declared these constructors. And we said our constructors can have parameters, right? What if the user want to give some initial values to it? What we can do is we can have an integer ID and a constant string of a name, right? What you can do is you can put ID here and put your name here. You are initialize your ID with the input parameter ID, and you are initialize your name with the input initialized name. So in your main function, in your student Joe, right, you can initialize it with 1,000 and the name Joe. Right, you can do that. So now the student has the initial ID 1,000 and initial value Joe. And you can do another one. For example, you can copy it to another one called a test student, right? Or you can give it a name, like Bob. All right, give it the ID 2,000 and a Bob, right? And you can say, how about Bob also register for the course called UFUG, right? So whether this name Joe are exactly the same as this Joe, it doesn't matter. You can put another name here, right? It's just input parameters, and then you can change their names. For instance, if this one is Bob, how about this one to be just a B, right? So B is just an object. It belongs to the class student, right? It has ID 2,000 and name Bob, right? So that's a variable name. Student is a type name. You are defining two students. So what you would do if you don't have a class, what you would do is, all right, let me create another one. Test 3, right? In your main function, it'll be really tedious, right? You would define a variable called Joe's ID, right, equals to, for instance, 1,000. Then you would say string of Joe's name equals Joe, right? And then you would say I would omit here. So if you don't have a class, right, you would define many variables like this, such as Joe's ID, Joe's name, then Joe's courses. But they are isolated variables, right? You didn't give them some meanings to it. So it would be, seems like they are different, just different variables, right? You can manipulate them as you like. And similarly in here, and similarly in the courses, right? Course ID, no, you have UG 2006 ID, name, students IDs, and so on. You have as many this stuff as you like, right? It will be very hard for people to read, right? Compared to reading this one will be much easier to read. Right? If these variables have meanings to, and they have some connections, making them just one class. Right, so that's the reason we introduce classes, and it's better when you are thinking from the human side, right? Object-oriented programming is basically thinking from the human side. If I have something to maintain, what are the things I need to maintain? I need to maintain a bunch of courses. I need to maintain a bunch of students, right? How they interact with each other, you can define them in your functions. And in the future, when you learn about this, when you learn about pointers, we will change here to be something like the students, student, right? In the future, I said, in the future we will learn pointers. So in your courses, you will maintain a bunch of pointers to students, and also in your students, they will maintain a pointers to courses. So they can, for instance, in here, they can manipulate some part in their, for them, they can directly release IDs, for instance, if I have some functions to do it. And yeah, many things can happen. But for now, we just assume they are grouping things together, all right? So this is about classes with the pointers and also with inheritance. We can do many more things. We can make our project as meaningful as possible. But at least for now, let's assume this will be some simple cases. Right. And let's see what we can do next. Right. All right. Here we said we put every implementations of a code of a function inside our class definition, right? Everything inside here, here, and here is called the class definition. In our class definition, we provided this implementation. And these are something we call inline functions. We want the compilers to somewhere. Whenever we say reg, call this function reg, it will call this function, right? But how about we don't want our functions, we don't want our machines to jump to this code, but we can directly replace this line. For instance, when the compiler sees this kind of implementations, what they will do is, when you call joe.read UFUG, what it will do is, it will directly call joe.courses.pushback UFUG. When you call this function, it will be, no, it's true. When you call this function, it will be errors. Right? You are visiting other people's private members. You cannot do that. But if you put the function calls like, I need to make it longer. Go to line 6. All right. Wait. Oh, I need it. Insert mode. Right. For any function or any implementations you put in your class definition, you are telling the compilers this function is very short. You can directly replace the implementations in your function calls. It's called inline functions, right? So whenever compilers see this show.ret UFUG, it may try to replace it with the implementations of your functions. So you will directly put this line here. So you can save the time doing function calls. It's called inline. But compilers may ignore your hints. This is just a hint to the compilers saying this is such an easy work, right? You don't need a function call. You can directly replace with this body of your function to where this line is called. It's called inline. Another way to write it is, for instance, this function, right? This courses 918. We also define this one as inline. What we can do in other way is we can three lines. Put it to the outside of your class, right? If I put it to the outside of the class, what you need to do is you need to put your class names in it. Right. Here is, we are defining the ref function for courses, this ref function, not the ref function for the student. Right. And then when we put it outside, so here I just need the definition of your class or declaration of your class. You are declaring such a class called course. And then you put these implementations to the outside. This ref function to the outside. It's still doable. You can put it in another file, it's doable. And this one is no longer this inline functions. If you want to make it inline, what you can do is you put inline here. When your compiler sees it, when your compiler sees this function is inline, they will try to replace this function call with the body of it. So there will be no function calls. It's just replacing this body in your function calls. All right, so what does it mean? It means in here, you have UG, this one, it will become UFUG 2601 dot student IDs dot push back of 1000. Right. So when you make this one inline, compilers will change this line into this line. So it will be much easier. It will make your program runs faster. But again, inline is just a hint to the compiler. Compiler may refuse to do that. Right? Compiler will refuse to do that, especially when the code are long and it's complex. They might refuse to do that. But for this kind of simple ones, you can easily make them inline. And what are others that can make them inline? Are something like this. Int get ID return ID. If you put your implementations inside your class definition, it's a hint to the compiler saying it's inline, right? It's inline. Because this function is so easy, you can just get inline, right? Whenever you call get ID, it will directly replaced by the compiler just to return this ID. And this is one way to declare inline functions. This is another way to declare inline functions. There are two ways to declare inline functions. Both ref and get ID are inline functions. Yeah, question?
There is a probability of this. That is, if we define an inline function out of the class definition, we should
put that in the same file.
Put the definition before the code.
Yeah, that's right. And the most common way to do that is we will define them in just one file. Right? If you implement this one in a header file called course.h file.
And the definition should be above main function.
Yeah, in your header function, you don't have a main function. In your header file, you don't have a main function. Yeah, that's something we typically do is putting class definition and the inline functions together in a header file called course.h. Yeah, HTTP or H, they are both fine. And typically they don't have a main function in the H file. Right. So yeah, anyway, this is the two ways to declare inline functions. All right. So any questions on inline functions?
They're inline because they're one line.
No, it's not because they are one line. If they are more than one line, you can still put it. This is the putting by you. You declare, you told the compiler this one may be easy to implement, and it may be easy to replace by the body of your function.
The void reg and get ID, those are inline.
Yes, these are inline
You
functions.
said they're hints because there's one line, or is a compiler seeing how long those are? Determine that
You can put it as long as you like. This one can be 100 lines. You can still put inline here.
I'm not talking about the inline, I'm talking about in the public.
This one,
Yeah, you said that those are inline functions.
these are inline functions because you said that. This is a function declaration. This is your implementation of the same function, right? These are the same function.
I'm sorry, the one above. The
The
one,
one above, all right.
why is that?
Why that is inline? This one is inline is because you put the body inside the function declaration, similar to the get ID. The get ID, because you put your body here, it's a hint to the compiler saying that get ID replaced by this body. But it's okay, you can put many lines in here, right? Compiler will ignore that. It's fine. It's fine. You put the implementations inside your class definition. It's a bad style, but you can do that. A good style would be just to declare these interfaces, these functions, just to declare them, not implement them. Implementing will be outside of your class definitions, so that when people see that, so let me see if we have a example. Let me go to the product. H. I should make it larger. This is the typical way when we declare a class. In a class declaration, right? Forget about this using one. In our class declaration, we have a class name, then public, and a bunch of interfaces, or we call them functions. And in these functions, we put some comments here. We put comments for these functions, like the read. What does it mean by the read? Like the it's better than. What does it mean by it's better than? You put some comments here. So when people read, they don't need to know the exact implementations of your class. What they need to know is, how can I use it? How can I use read? How can I use it's better than? Right? This will be in one header file called product.h, and it declares all these functions. They basically, most of them don't have any implementations. But if you want to put inline functions should be in the same file with these class declarations, and you can declare them to the outside. I don't know if I have a inline functions here. No, I don't. Right. And then we have some private members. So this would be the basic way. We typically don't put implementations here, but you can do that. You can do that like this one, right? You can put the implementations of any functions in your class declaration. It's also fine, but the best style would be like this. The reason we don't put implementations here because when we include as more and more functions, it will be easier to read, right? For instance, this product class, if it can display in just one page, it will be good, right? If we put implementations here, it'll be very, very long. It's very hard to find them. It's a style issues or readability issues. Any more questions?
You said last lecture the difference between a strut and a class is strut by default, all public, and class
Yeah.
default by default. You're still defining both.
Yes.
So what's the difference, or when do you use one?
Okay, so yeah, good question. So if I delete this one, it's still valid, all right? This student class is still valid. The difference is all these functions, all these members are private. No one can call any functions, no one can access anything inside your class. So that's what we mean by default. It is private. By default, class is private. But what we can do is struct, right? If we do it in this way, all these members are public. All these members are public. So that's the difference between a class and a struct. So in the future, I believe most of you will just use a class instead of a struct. There will be some of the functors, right? When you are defining a struct of functions or what should I say, functors? Maybe you will learn that later. Anyway, so most of you will use a class instead of struct. And in a class definition, we need to specify what is public, right? Because if you don't say that, everyone is private. So you need to say something about public. If you put public here, it means everyone is public. So then you need to specify which part are private, right? So that's the basic process. Any more questions? No? All right. So as you can see, this is the product.h file. And let's look at the product.cpp file. Right? In here, we first include this public product.h file so that we can include these definitions of your product class. And then we want to provide the implementations of every function you declared in your header file. So for instance, you declare what is a constructor, what is a constructor with parameters, right? You can visualize them with name, price, and a score, right? You have also defined what is a read. Then you can put implementations of read here, and you can put implementations of what is better than, right? These are the typical way we define a class. It contains two files, header file and source file. Header file only declares the interface, put some comments here to explain how to use it, what does it mean. Then in your CPP file, put the implementations of every functions. And when you have more, so here are just two, right? One header, one CPP. And what you can do is you can have another one. Where is my shop function? So this is the shop. I move it to the right, right? If I have a bunch of products, how about I define what is a shop? So in here, as you can see, it still only include product.h file. It didn't include product.cpp file, right? Which means you don't need to know the implementations of your product. It only needs to know the declaration of your product. And in your shop, you can use product like this one. So it means you can declare more and more as you like. And I didn't provide the CPP for shop. So for this one, and one thing I typically use is that, as you can see here, I have std, right? Never put using namespace std in header file. In header file, just to put the full name here. It will be a, you could say it's a style issue, but it's more a compilation issue. Sometimes you will ruin the whole namespace if you put a using namespace in your header file, because header file will be included by many other files, and when they have conflict of the especially namespace or the functions, for example, inside of one space, you have the functions that have the same name, there will be a conflict. But just to remember, don't use using namespace std in your header file, but in your CPP file, sometimes it's fine, right? Sometimes it's fine. It's not that stringent, but CPP file in your source file is fine. In your header file, never using this namespace std. So it will also introduce another problem. Is writing in your header file will be very long, right? Like this one. This one is short, but how about we have another one called using std factor of a vector, right? Something like this. You can make it longer and longer and longer. When in the future, when you learn something like the map, then it will be a map of factors and then map of something, then that line will be very long. So we introduced something called aliasing, which means the same name. Let me make it large. We want to simplify the complex type. Right? Remember, in your header file, we cannot using namespace std. We need to put std here. Right? You could also introduce your namespace, and it would be your namespace, the vector or some object you have defined. So in here, right, what you can do is, okay, how about I define vector of double to be a new name called value. Then in your definition below, you can just using value to do that, to represent std vector of type of a type. So in the old ways, people typically like to use type define, right? Type define, and yeah, another reason we use type define is like this one, such as account. Right? In our account, we rename aliasing means a new name. We use the name money to represent a double. So in the future, whenever you say, what's the type of your balance of your account, right? The type is money, which means the type is double. It's a new name for double. But in the future, when you want to change it, I don't want my type of my balance to be double, right? How about change it to float? The only location I need to change is here. Type define float as money, and all the remaining positions, all the remaining declarations, I don't need to change, right? So that's the beauty of type define. But this is not the typical way I would like to use. I would like to use this name called using, because it's much easier to understand. So the same, I want to define a new name for the type vector of double. What I can write is I can say using value equals vector of double. Right? They are basically the same meaning. The only difference is you are using type define, I'm using the using. That's the difference. Right? Or you can say using money equals the double, then you can continue to using this double. All right, so let me see what will I do in here. Right. For instance, if this one is such a complex one, what I would do is What I would do will be similar to this, right? And I can declare some functions like right? I can make it simple to use, something like this, or put it into the parameters of your functions. They are all fine, right? It's just the style issues. You can use type define. I like to use this using, and in this product .h file, as you can see, this line using score equal to int is actually a type aliasing. I'm using a new name called score to represent these integers, right? And then you can see here, right, I have a type, which is a score, and its member is called score. The beauty of it is in the future, right? If I don't want to use int to represent the score, I can easily change it to something like the double. And everything else just remains the same. All right. Any questions on type aliasing? Giving a new name to the existing type.
Does it have to be categorized?
No. It's just a name, right? You could give any name, score, it's fine. Yeah, it's just a style issues. I like to using capitalize for anything other than variables. And I remember in the old days, you guys asked me what is namespace, right? The way in large companies, when you are maintaining a number of projects, what you need to do is you put a namespace here. Right. You group everything in a new namespace. For instance, I put a namespace Yang here. And in the future, whenever you want to use it, you need to put something like that. Let me show you these. Yeah, similar in here, right? In here, if you want to define all the functions for the product, oops. Let me skip this. In here, whenever you want to use a product, right? When you include this product, in here, you need to put something like this. Like I said, when it becomes a industrial level code, this type will be longer and longer and longer and longer. It'll be very, very long. Right? And then never using namespace here. Right? If I define some functions in my namespace, it will conflict with the namespace such as the STEs and so on. So these are the better way to do it. All right. This is how we use namespace and aliasing, namespace and aliasing. These factors and some other things, C in, C out, they are defined under the namespace of STD. They don't want to conflict with other functions with the same name defined in your own namespace. So that's how we use namespace. All right, any more questions? Namespace is to grouping things into, you can think of it as a package or something, and then everything can be isolated, right? Global variables, and also these type definitions, right? You can define a product. How about in your namespace, you define another product, right? You can use a namespace plus product to refer into different things. Right. So that's the aliasing. Yeah. In here is about the, wait a minute. Yeah, accessing when you are trying to implement a non-member functions, right? A functions outside of your class to access something inside the class. What you can do is, for example, you can call this function. You can create a new one to call a function. This one is doing matrix plus, but last time you told me that you haven't learned the linear algebra, but you can think of just some type, right? Some type, another type, and these are just two numbers. You can call this number plus another number, right? You can do something like that. Let's skip this one because you didn't learn what is a matrix. Inline functions, we have done that, right? For the we have a lot of get functions, right? Sometimes when we are trying to make every member's private, sometimes we have a lot of get functions. And for these get functions, their function body are quite simple. For example, if you want to get the seconds, you just return the seconds. You can make them inline in your function implementations. Whenever you put make some function inline, the implementations should be in the header file instead of this CPP file. All right, so that's something we talk about inline functions. And when inline functions is called, right? If we have a time t, we call get seconds. What compiler might do is replace it directly with t dot seconds. So there will be no function call here. And function call is actually very time consuming, creating some stack and using some heap and things to maintain the variables and the registers. Anyway, so this one will be much faster than this one. And when you directly write t dot seconds, we said it's an error because you are accessing the private members, but the compiler can do that. Compiler can do that. And the inline member functions have to be defined in the header file, or we say it should be just below this class declarations. Two ways to define inline functions. Right, one is just putting the function body inside your class declarations. This is one way. Another way is, but we said it will hurt the readability because you will make the lines more and more. We will make the header file longer, and it's common to avoid putting the implementations in your class definition. Right? In your class definition, just declare these interfaces, and outside of your class definition, you put the implementations. It's just a common practice. Don't put your implementations as a inline or put them into declaration of your file if it's longer than one line. But it's not absolute, right? If it's if it's 2 lines, 3 lines, maybe okay, but it's just a common practice. Right? People don't like the ways you put a long implementation body in your class declarations. And then we should note that here is inline is just a hint to your compiler. It's not a command to your compiler. Your compiler can refuse that. Your compiler can refuse that. Your compiler could ignore this request.
When it ignores it, what happens? What does that mean?
It will go back to the original functions, right? It's probably be replaced by this, but if GCC ignores this one, ignores your inline request, it will just be this one. Jump to your functions, execute your functions. All right, any more questions about inline typing analyzing? No, let's go to static members. If you guys can still remember, static in a function means it will be created only once. Whenever you call this function, it will always using the same variables, right? Like when we count how many times a function is called. How about a static member in a class definition? It means this member belongs to the class, not belongs to the object. Let's see if we have an example. Yes. Right, here is an account class definition. Like the original one, we have a normal variable called the string name. The account name, it belongs to every object. But we have a static member called static int account count. We want to count how many accounts are there. Then we can use this static variable, static member, to represent that. So this one belongs to the class account, doesn't belong to a single object. So as you can see, we create account A, we create account B, right? A has a name called A, B has a name called B. And when A is called, it calls this constructor, right? It will provide A as the string name. So it will initialize your object A, A's name to be the name you provide, which is A. And also we will increment our account count, right? The number of accounts. Similarly, when B is called, we will initialize the name with a B, and we will increment the account. And after that, we can see out A.getCount. GetCount just returns account count, right? And then we will see out B.getCount. Then we will see out account.getCount. So what's the output? The same, right? Output 3 twos. Yeah. Wait, yes, I initialize this account to be 0. And when this one is called, this one's 1. When this one called, this one is 2. Right. So it will output 3 twos. So in here, as you can see, a bunch of differences. First one, you need to initialize this one outside of your class, right? You can maybe you can put it inside. But anyway, I would prefer this way. Declare, for example, define this starting point of your account count to be 0. Right? You can do that using account column, because this variable belongs to this class, not belongs to a single object. You can call it in this way. Okay. And as you can see, this get count, you have to define them as to be static, so that you can return these functions, return this static member, right?
You can access account.
Yeah.
Those private.
Wait. Oh, this one is not accessing.
Yeah.
It's a declare. It's a yeah. You basically declare the initial values for it. I believe yes. You can try that. Good question. Right. So these are the static member. So the meaning are very similar to a function's static variable, right? It just kept there whenever function is called. Here the same. It's just there whenever an object is created. This is very useful. These static members are more useful than functions static variables. This is static. All right, here we can, for example, we can implement a class with the following properties. Right? A class has a certain fuel efficiencies. How many liters do you need for each kilometers you drive? Right? And a certain amount of fuels in your gas tank. This is how we use it. Then you need to implement the function body of it. For example, we can declare a car, which is the beamer, and the fuel efficiency is 29, which means for every liters per kilometer or per kilometer per liters, I don't know, anyway. And we just assume for every liter of gas, it can drive 29 kilometers, right? And we can do something like add gas. We can add 20 liters. We can drive for 100 kilometers. What's the remaining gas for it? Here are something that how to use it. So the question is, how can we implement such a class? And we can also implement another class called a gas station, right? And a gas station, we have, for example, the capacitance, or no, this is the price for a gas, which is, for example, 100, right? 100 per liter, and we can say, we can query this object. This object will return us if I need 20 liters, what's the price for this gas, right? You can do something like that. Also, we can, for example, given the distance of each gas station, and each gas station has its price, right? Has its own price, and you can return whenever you need to add some gas. Which station should you go? Right? You have a distance from your current station, for example, to each gas station, and each gas station has a price for it, and you can write a function to choose which gas station is your best choice. Right? You can implement something. This would be a little complex, but it's more close to the real life problems, right? These are the object-oriented programming. They will define class, car, gas station, right? And you can use them to define some of the functions. Whenever you implement these functions, you can forget about that. So for these questions, it's actually very easy, right? You can try each one by one, and which one gives you the lowest price, and also what is your remaining gas, because maybe a cheap one is longer than an expensive one, right? You have to decide which one you should go. There are some choices, and you need to choose them. All right, you can do that. It's not complex. It's just take some time to write it down. It's tedious, but it's not that complex. All right, file structures, we have already said that. So especially when you are working in a large team, you guys want to split your code into separate files, right? Everyone implementing different classes, and what needs to be agreed on is the header files, especially the interface of each class. Right? If you are working in a group, you're responsible for implementing some of the classes, but the interface you guys need to agree first, right? Especially for a large group. And you can separate them into different source files. One benefit is compilation time. Whenever you separate different classes into different files, whenever you modify one file, you don't need to recompile the whole project. The only thing that needs to be recompiled is the ones that be changed. And separate them into different files. So in a header file, right, we typically do definition of some constant, definition of the classes, and declare, remember it's declare of some non-member functions, and also declare of some global variables. And in the CPP file, or we call the source file, we will define what is the member functions, define of the non-member functions, and define of the global variables. Yeah, here are just some suggestions. You can ignore that and put everything in just one file. It's also fine. So, in order to support separate compilations, we need something called this guards. Right. And so it's called if not defined something, then we should define these things, and then we will end of define. So let's look at our example of product. Yeah, here. The first two lines, if you have never defined product H, you can define product H here. And at the end of your file, there will be an and if. Right. So what does it mean? It means when you are compiling multiple files together, right? Remember here we have product.h. In our shop, we also define what is a, we also include the product.h, right? And in our product.cpp, let me see, product.cpp, we include the product.h. If we don't have this, if not define this macro, if you compile multiple files together, this header file will be included and compiled twice, 3 times, 5 times, and more, right? And some of the global variables, if we define here, they will be a redefinition or redeclarations. So you can put it something here. It means, so when you compile for the first time, right, you have never defined the product.h. Then says you can start defining this one and reading everything and compile these header files. When the second time another file says include product.h, because product this one product_h is already defined once, right? So this if not defined is not true anymore. So the compiler will skip these header files, directly use something that's already done. So you will skip this double compilation problems. All right. So that's the something you can use when you are having multiple files to do the same one. Right. This is this name doesn't matter. You can use any name, but typically we would like to use the same as the file name. Right? If your file name is product.h, you can use something like the product_h. But this name actually doesn't matter. You can use any name. And nowadays, actually, someone would like to use programmer once. So instead of these 3 lines, if not defined, and if, they would like to use just one line, programmer once. Right. This one, if you put into the first line of your header file, it is the same as this if not defined style. But I would prefer this style because it's the standard one. Programmer once is not a standard one, but it's widely supported. Whenever you use a compiler, most likely it is supported. So you can also use this one. It's fine. So yeah, and in the source file, product.cpp file, you should include this header like this, like include any of the IO stream or any other function, any other headers. Right? They are just a declaration of your functions. And typically, we don't put a main function here. Right? We are just declaring some of the files, some of the classes, but it's okay. You can put that. All right. So here is an example. Right? In our shop function, because we use product, we can include this product.h. Only include something that is useful to you. If you don't need, for example, IO stream, if you don't need a C in, C out, skip IO stream, right? If you don't need some other classes, don't include them. Only include the things you needed. And also in the main function, right? In the main function, you can include this shop.h and start to use this shop class. You can define an object for this shop and then do some other work. And sometimes when, for example, if you need to return some of the product, you could also, if you need to use product, you can put it here. If you don't need to use product, you can skip this line. And you can try it if you remove this include guards, which is if not defined. You can try to remove them and compile it to see what will happen. All right, so for making files, right? This is the old ways we write a making file. What does it mean? We want to compile to an executable file called shop. This shop depends on shop.cpp, depends on product.cpp, depends on main.cpp. How can we compile? We compile this other dependency. The first line is a dependency. Second line is the way we compile the code. Right? In G++, -o means the output. Output is the shop, and all the remaining are the source files. We put them together, and we can compile them. This is the old way to write the CPP file, the make file. What's the new way? The new way will be, let's skip this first line. For every class we declare, right? We declare product. Then we could say something like this: product.o depends on the CPP file and the H file. And yeah, sometimes you can ignore that H file. Yeah. Anyway, this is the typical way. You can say product.o depends on these two, and this is how you compile them. And the -c means don't leave them for now. And the shop.o you can do the same way, and the main.o you can do the same way. And what is a shop? If you want to exit and you want to compile shop, it depends on all this object file. .o is the object file, which is the intermediate file format. And you depends on all of them, and you can compile them using these commands. So what's the benefit of this one? So in here, whenever you change a little bit in product.cpp, for example, this line will be called. So everything will be recompiled together. Even though shop.cpp and the main.cpp never change. But in here, it's different. Because you never change shop.cpp and shop.o. Shop.o doesn't change. So it will not recompile shop.cpp. Similarly, main.cpp, they will not recompile. The only thing they will recompile is product.o. Right? Because your product changed a little bit, they will recompile to generate a product.o. Because your product.o changed, they will look at this one. Because shop depends on product.o. So because your product.o changed, it will recompile shop using this command. So for a large group project, when there are more and more CPP files, if you want a faster compilation, this one, if you modify only a little bit, this one may take days or hours to compile. But this one maybe just take seconds to compile. So whenever you change a little bit, want to see the output, compile it for seconds, then run it to see the output. But here you need to take hours or sometimes days to compile, especially for large projects. Right? Any questions on this makefile? So don't worry, we will provide you with these makefiles, but the only thing you only need to know what's the meaning of it. You don't need to write it by your own, right?
So it does it by itself what it change based on it.
Yeah, it actually look at the timestamp. Okay, if your timestamp, if the output, your timestamp is older than me, then we will execute this line. Yeah.
Professor?
Yeah.
You take an example of the task.
Okay, so this one, let me see if I changed anything in the shop. Yeah, here I need to delete this one and namespace. Keep it. And here is the products.cpp. Did I change anything? No. Okay, I can close it. And in my shop .h, yeah, what I changed is here, right? If I can remember, I need to copy that. I don't have this function. I don't have the namespace either. All right, so I have the product.h, shop.h, and let me see what is my make file. Right, exactly the same as the one I showed in slides, right? So what I can do is, let me see if I can, yeah, I will keep it. Let me see, yeah, I have two terminals. I can see if I can make, right? The first time when I call make, it will try everything because I never make it before. So how about I change a little bit in my product.h. Let's see what will happen. Let's see if I comment this line, right? I make in here, I make a small difference. Initially, this one is there. Now I'm commenting out. What we are expecting is it only recompiles this product.o and also the final one. Let's see. Let me make it smaller. Let me call make. Right? All the others, like this shop.o, main.o, doesn't change. The only thing we change is in the product.cpp. So we only cause this compiler to recompile this product because product all changed. So the final binary shop is changed because it depends on the product.o, right? So there will be only two changes, two recompilations. So that's the difference. Any more questions? No? Yeah. So I believe that's almost, oh wait, we have one more. It's the order of includes. So now we have a bunch of includes, right? If we look at this, do we have shop.h? Right, we have something like the factors, we need to include product.h. We have many different includes. So one of the style I just follow is the Google's C++ style. First one is the related header. Another one is the system header. Another one is standard libraries, then others. So what is related header? So related header, if we look at, we put it here, yeah. Yeah, it's not following. All right, what is related header? In your product.cpp, product.h is your related header. So you could, some orders, right? You could include product.h to the first position so that other people knows what are the header files you are referring to. And then you can include some of the system headers and also standard libraries. You can, for now, you just think of them as just one type of headers. They are headers provided by the systems, like the IO streams, factors, this type of these headers. You can put them into the second one. Let me use an example. Wait. Okay, you can put more, right? You can include something like the factor and include string and so on, right? These are called these standard libraries. Standard libraries you can include next. Then the last one is the other libraries, like the functions. Some other libraries are written by yourself. So then if you write something called utility.h, I just made an arc, right? They are just some header files written by you, but not directly related with the product. You are just using some of the functions they are implementing. You can group them in this way, right? It's just some style issues. You can ignore this kind of style guidance, right? Here is something that we typically do. Product.cpp, first line, include product.h, then some system libraries, then some libraries defined by yourself. Right? Yeah, I think that's the end of the lectures. So we will take 10 minutes break. Then for the remaining of the class, you guys can ask me questions related to anything that we have covered, or question about the homework, question about the lab, anything, and you can ask me in Chinese as you like. All right? Yeah, let's take a 10 minutes break.
对那个 inline 有点懵。
哦
它
，OK，
那个到底是在类内和类外的定义有什么区别呢？
都一样，都是
都
一样，
是一样的。那
对
加个 inline 的话，
就是大家有时候会喜欢那样子定义，
就是我在里面写个声明，然后我在类外面写个 inline。
对，它就是一个 inline function，但是不代表 compiler 会同意你这样子做。哎，在哪来着？应该是在前面还是后面？我也忘了。在
好像30多页，30。
这里啊。对，你可以这样写在里面，这样是一个 inline function，
嗯
这样也是一个 inline function，它们一模一样，没什么区别。
嗯，
这是什么情况？
就没什么区别。
对没有任何
在
区别
类内类外都可以
只。是有些人喜欢你写在里面，有些人喜欢写在外面，但大部分情况下我是比较喜欢写在外面，因为我不想把那个 class 的定义写的太长。大家可能就一页纸把它打印出来看也有。
你是用那个我记得看出来
是能透露一下那个考试它你写代码是要写整个文件还是？
这个可以下半堂课你再问，这样大家都能听见。
给一个 example。
假如我要复合文件的话，那能直接复这一个，就是写那个考试的时候。
大部分情况下不需要。
那我能不能写？
他如果写了，
如果你能够把这个有什么好处吗？你
这个是
这个
引入这个就不用引入其他的，
就是有点懂。
那不要这样子。
这是什么玩意儿？
哪个？
这个报错啥意思？
这个应该是你的那个compiler的问题，路径啊是依赖。
怎么设这个啊？不会调。
我也不是很清楚它怎么设。你这个是什么？这个是 Windows
就是
吗
Windows，就刚才
嗯
是就是我写完这个和这个之后，我又建了个文件，然后同时引用了同时包含了这两个同文件。
你在 terminal 里面编译会怎么样？在 terminal 里面编译，这个里面，
这里面
PCC 编译会怎么样？
就是它是正常的，但是它不会报错。
确定我不知道 Windows 怎么。
它们运行的，它一直会报错。
是这里的对吧？
对，就是如果说有那个闷函数的话，是可以运行的。
不在这里面。
但是我这里面没有闷函数，所以应该是不能运行的。
是这样是吧？不是的，是哪个文件夹里面？
哦，我来。
你先进去，我先
好
研究别人。
就是这个题，我不知道你们知道这个题吗？Game Story 是 undergraduate 的。这个题，我目前的问题是，我现在是 partial，但是这个 partial 很奇怪，就是我全都是 DLE。
OK， 你可能跑得太慢了，是一个递归慢，这个什么？
就是时间复杂度太高了。
对，是一个递归，应该这个时间复杂度太高。它的问题是什么问题来着？
它的问题是
不是那个 maze 吗？那个是另外一个。
不是妹子那个这个是妹子的升级版。
OK， 它有什么增加的吗？
它意思就是给了一个这个东西
然后
这个地图呢，你要去找到每一个 O 能够通向多少个 O，
通向多少个 O？
对，
可以，
然后最后去把这个输出出来。就是发现这个题好像不太好做，因为时间复杂度会超掉。
你是怎么运行的？我看一下，你是怎么编的？
先就是硬去搜，
或者这个，
对，
是用它是上下左右都可以对吧？
对，
那是时间都会超的。你要想什么样子哈？比如说我先去搜了这个，再搜了这个， 这个可以搜右边，这个右边可以搜上面，上面可以搜这个，这个又可以搜下面，又可以搜这个，我可以无穷的转圈，我可以不用停下来。
啊，没有，我搜完之后，就是开始认为这是 Word，就是搜完之后就证明它是 Word 了。
哦，
对对对，就是把它变成 Word。
OK，
但是还是会抄。
这会抄。这个得仔细看看它到底出现什么问题。
就只过了一个样例，其他全是抄的。再仔细看看。
对对对，
这种题不会考吧？我感觉这个有点过了。
离谱了。
这个
意思
不是，是迷宫升级版。
哦，对对，那个有点过难。
这个这个要用那个什么宽度优先输出嘛？
那个就不是不是 recursion， 你用 recursion 的话是可以不用这个。
低估是721啊。
可以，你在这里就是外面
怎么感觉这么像 Python？
不，这个就是 Python， 对不起。
那 Python 肯定低吧。
C++ 那个在这儿，C++ 那个。
你在这里加个 state int visit 一个2位数组，然后你每次到这个点，
你用 visit 可以
visit 标为1，然后 visit 等于1的话就不要走这里。
对，就可以设计一个，其实 TA 有 provide 一个类似的，我看看啊，它写在哪里？这个就是有个 visit， 每一次 visit 的过了，你就不要再 visit。就 TA 有 provide 过这样一个样例，虽然这个代码写的我不是很喜欢，
你每个点这样的话就只会被走一遍。
对，这样在 recursive call 的时候，它就永远都只会走一遍，你不用去考虑把它复制成 W 啊，复制成。对，你可以maintain这样一个数据。
可以试一下。
对，你可以看一下。
然后还有
这个在 OJ 里。
OJ 像这种题 ，OJ 能不能公开 AC 的人呢？就是或者开一个讨论版。就是开一个讨论版，有愿意进去放的就可以放。
没明白这是什么意思？
就是类似于log，有一个 discussion。
那为什么不在 canvas 上 discuss？
对啊，为什么不是？
对啊，为什么不在 canvas 上 discuss 呢？有很多人放在，你看这个，他们就放在 canvas 上 discuss， 对吧？这个问题什么问题？大家一起看。
我认可尺度的，我先打。
这个
它的意思是偏
可以运行对吧？
对，但是它就是意识到这个错。
不，我的意思你在 terminal 里面打代码，
这次还是
OK。这里有个7++是吗？
我不知道我是什么呀
OK。除了 part 那个还有什么 shop 是什么？它都是什么？没有main函数吗？还是什么？
有main函数呀。
不知道，反正就是杠。
重复定义的，他说你。
杠是这是杠 C。
可以重复定义的这个 print。
它现在就在最。
你可以看一眼。
就那个忘了加那个
它都加了。那你这个这里呢？
用一行的。
那你的 shop 呢
？shop 也有 print。
shop 也有 print。
但是如果不加个 print 的话，在 shop 里就
两个main函数，这里一个main函数，一个 product 里面有个main函数。
因为这两个它是独立的文件。
OK， 那你就是不打算一起编译啊？只打算
就是分开的。
OK， 那你就这样就可以了，对吧？
投文件。
没有。你可以再试一下 shop。
你们也不报错。
为什么会报错？
刚才为什么会报错呀？我也不知道呀。
真别的字我都不太懂。
shop 也报错。OK。
那为什么刚才
刚刚是这个问题，它有时候Windows 下的配置就是有点复杂。是的。
你们想问那个刚刚想说的那个 if not define 就是那一页。
OK。
意义在哪呢？就我只明白了它的格式是应该这个。
好，就是你 product 里面你 include 了一次 product 点 h， 对吧？然后在我的另外一个 shop 里面，我又 include 了一次 product 点 h。如果我没有那个 if not define 的话，我在编译这个的时候，我会编译一次点 h 文件。我编译这个文件的时候，又会编译一次这个文件。然后你把它们连起来在一起的时候，它就会发现你重复定义了很多遍什么叫 product。对，所以你要加那个 if not define， 那个是让它只编译一次。
就是其实我是可以有很多的这种分开的投文件的，但是
很多的 CPP 的 source 文件，这个是 CPP 的文件。对，就是在我的 make 文件里面哈，我有 product 点 CPP， 它是 include 了 product 点 H。我有一个 shop 点 CPP， 我也 include 了 product 点 H。在我的 main 函数里面 ，main 点 CPP 其实我也 include 了 product 点 H。如果我没有 if not include 的话，它会被编译3次，然后在最后连在一起的时候，它就会报错。
哦，它会报错吗？
对，compiler 就会报错
的问题。
是的，compiler 会报错。
连在一起，
什么叫连在一起？
这什么叫连？是一起
OK
编译吗？
如果我把它去掉哈，
然后你可以分3个文件，分别是
好，这3行我去掉了哈，
嗯，
我保存一下。
第3个以后，然后再把这3个
make file 我没变哈，我可以比如说先 clean 掉，我再 make 一下，utility 呢，这是在哪个函数来着 ？product 点 cpp， 你看 redefinition of class product。class product 的这里，对，因为有很多的文件，首先这个 product 的时候，在这步的时候，它已经把这个编译了一遍了。第二次你在做 main 的时候，它又把它 include， 然后再编译了一次，这个时候就会有一个 redefinition， 就你第2次定义。所以你需要。
我一直在跑这个，我跑了很多次，
就你每运行一下这一行代码，
都要跑一次。
对，都要编译一次这个东西，都会重新定义一个叫 class product， 然后它就会有一个 redefinition of class product。对。
就是说，这个是在写，这个是在写，比如说这种，
就是在多文件管理的时候，你多次 include 的时候，多次 include 同一个文件的时候，就会出现这种问题。
就是说，我想搞多一点库，然后自己先写一个库，然后再用这个库的时候，
对，
就会出现这样。
是的。
好的，好，明白。
还有就是我想问那个 make file，底下的就是他们就比如说找一行的话，就我们需要明白它
这个吗？
对，比如说这样，我们需要明白这些是什么意思吗？这加杠 C
杠 O 你应该是明白的，杠 C 你应该是不明白的。杠 C 的意思就是还没有 link 起来。
就是单独
对，单独编译。我现在是没有 main 函数的，所以只有在最后一步，我不加杠 C 的时候才是有那个把它编译成一个 executable 可执行文件。
二进制文件。
对，其他的都只是一个中间文件而已，我没有把它全部连起来。
对，它分4步。
对，它有很多步，它是 preprocessor 啊什么
因为杠 E 杠 S 杠 C 杠 O， 对，最后一个不加。
对，就是其中所有的中间文件你们都按照这样子写，加杠 C 把它加上去就可以了。最后一步才把它连在一起。